Okay, let's get started. Welcome everyone. So good morning. So this month's CEBRA webinar, would like to welcome everyone to it. For those I haven't met before, my name is Julia Wells. I'm the Assistant Secretary here in the Biosecurity Sustainable Funding branch here at the Department of Agriculture, Fisheries and Forestry. Before we start, I'd like to acknowledge the Ngunnawal people as the traditional custodians of the land that I'm meeting on today, and many of you also are. And I'd like to also recognise other people or families with connections to the land of the ACT region. I wish to acknowledge and respect their continuing culture, the contribution that they make to the life of this city and the region, and I extend that recognition to the traditional custodians of all the other lands on which you are all gathering with us today, and to all Aboriginal and Torres Strait Islander peoples attending today's webinar. We've got people from all over, I'm sure, attending, and we really welcome that diversity. Before we start, just to let you know, as you can see, today's session will be recorded and it's available on CEBRA's YouTube channel for you to look at afterwards or to share with others. We'll be having a presentation and then questions at the end. So at the end, you're either welcome to put your hand up or put a question into the chat panel. For those of you who might be new to CEBRA, just to give you a quick rundown, the Centre of Excellence for Biosecurity Risk Analysis, it's a long-standing biosecurity research initiative hosted by the University of Melbourne. CEBRA is focused on bringing scientific rigour to how we understand and manage biosecurity risks, bringing together global expertise to tackle real-world challenges and deliver practical outcomes. Today's CEBRAnar is a significant one as we celebrate 20 years of CEBRA. In this special edition, we're joined by Professor Andrew Robertson and CEBRA's ever-distinguished chief investigators who will highlight the impact of CEBRA over the past 2 decades and how CEBRA researchers actively shape how risk is understood and managed in an increasingly complex global environment. Along the way, you'll hear how biosecurity has changed over time, insights on the most critical issues facing biosecurity today, and what biosecurity might look like into the future. Known for his engaging and energetic style, Andrew is Executive Director and Chief Investigator at CEBRA, joining in 2009 under the original ACERA model, and has led the program since 2017. His enthusiasm for CEBRA's work is infectious, inspiring many and bringing biosecurity risk analysis to life. So please join me in welcoming Andrew and the team. Over to you, Andrew.
Thanks so much, Julia. Am I coming through loudly and clearly? Happy days. Folks, it's just such a pleasure to be here. I've got far too many slides to dally, so I'm just going to leap into the presentation and see if I can get this all right. It's going to do PowerPoint live. Do we see the first slide?
Yes.
Thanks so much. Excellent. Okay. All right, here we are, 20 years in. Gosh, I want to start with a couple of essential facts. CEBRA began in 2006. I'll talk about the trajectory in a moment. CEBRA has gathered from various sources a total of $76 million since 2006, which is an absolutely mind-blowing statistic for me. And that includes the projects and project work that have been undertaken by our sister organisation, CEBRA, run by Professor Tom Compass, and Biosecurity Commons, managed by Dr. James Kamak. Our database contains a total of 366 journal articles and 178 peer-reviewed reports and 2 books. And if you want to play fun top Trump style games, you could jump on that database and do a search on author names and see which ones come out the most, both in articles and in reports. Fun for all the family. So I'm going to take now just a moment to walk through our timeline. I know that you're here to listen to the team and not to me, so I'm going to keep this tight and light. We started in 2006 with what I've described winningly as the roughest years. And the times were rough for my predecessor, Mark Bergman, because the operating model didn't really fit. It wasn't really fit for purpose, let's say. In ACERA 1, that's the first sort of tranche, the operating model was basically academics would dream up ideas and pitch them towards staff, pretty much like throwing watered toilet tissue. And some would stick and some would not stick, and they would carry out the projects that stuck and write reports, or sometimes not write reports. And and the delivery was therefore highly variable. And then DAF would receive these reports and look at them and say, well, these don't really engage with our core challenges. Thanks so much, but there's not much we can do with that. And that was 3 years of hard yakka for my predecessor, Mark. At the end of which there was a sort of deep soul searching to say, do we really want to keep doing this? Do we really want to try something new? And Mark and the DAF executive had a long heart-to-heart and decided they would keep trying, but they were going to change the model. And that brought about ACERA 2. And there were two key changes in the model for ACERA 2. The first was that instead of ideas coming from outside DAF, the ideas would be largely driven from inside DAF. And that is a huge scope change, because that meant that DAF was firstly able to try to identify its core values and interests and put those out in front of CEBRA or ACERA for engagement. But it also meant that DAF had to be vulnerable and had to talk about its true issues and perhaps be a little less avoidant. So those are two sort of signal changes. The other key change that DAF advocated was, instead of farming out projects to individuals, that Mark should recruit some people to work full time. And Mark, in his vast wisdom, recruited Susie Hester and myself to join ACERA in 2009. And that was our new beginning. We started this entirely new model. It ran with great success for 4 years, at which point the projects expanded to cover New Zealand as well, and the funding model expanded to cover New Zealand. And we dropped Australia from the name of the centre, and we added biosecurity just to enhance our focus. After 4 more years of very successful engagement, Mark left for pastures greener, mainly Imperial College London, and I took over as the director in 2017. Halcyon days, and this was a substantial regime change, because Mark asked me, are you okay taking over? And I said, well, I'll be fine as long as Ron, the chair, and Ange, the business manager, as long as they stick around and stick with me. And within a month of Mark announcing his departure, they both vanished. So we had a total turnover at that time, and that was, well, taxing, let's say. But it brought forth some interesting challenges, and we are where we are, and we mustn't complain. In 2021, we expanded our scope. With encouragement from DAF, we started looking at ways that we could provide biosecurity risk enhancements to a wider range of stakeholders. We're thinking the states and territories, we're thinking industry, we're thinking even industries in other countries, looking at ways that we could take the corpus of work that we had developed and enhanced and provide better biosecurity outcomes to this wider range of stakeholders. And we've had great success doing that, and we've had really fabulous challenges and developed really wonderful working relationships, and we'll talk much more about one of those shortly. And finally, we have the new scenario, the new tranche, CEBRA 2 still, 2025 to 2029, the next 4 years, and we'll be hunting impact in this time and looking for ways that we can enhance biosecurity risk management outcomes. So very, very high level summary. I'm going to just talk about our publications briefly. I've made a little plot because I'm a statistician. And what I've done here is I've just made a little bar chart of the count of objects from our research database, which is more than 600 objects, I might add. Looking at the distribution in time, we've got a fairly flat distribution of reports. We're doing sometimes something around 6 to 10 of those every year, which is actually a very high rate. But you'll notice in the latter half of the years, we started to do fewer reports. That's because in consultation with DAF, we've been doing larger, deeper projects. We have a concomitant drop in the number of journal articles. We have a huge pulse in book sections when we published the second book. And we've started to see the CEBRAnars coming out in those presentations. So we could trace the history of our posture in these production trails. And I, for one, am incredibly proud of what the team has achieved and is reflected here, albeit in a statistical form. Okay, I move on. And now I invite Jimmy to talk about Biosecurity Commons. And Jimmy, just give me a go when you want me to change the slide.
Yep. Thanks for that. Hi, everyone. Thanks for having me here today. So Biosecurity Commons, I hope most of you at least know what it is, really came about because after 15 years of CEBRA and ACERA, we were developing a lot of technical reports, and we were developing a whole heap of types of risk analytics to inform a whole heap of decisions. But often they were put into technical reports or peer-reviewed scientific papers, and it made it extremely hard for decision makers to actually use and implement these models. And so part of the reasoning for where Biosecurity Commons came about, which is a cloud-based analytics platform that allows users to relatively easily fit these models and use these models to inform decisions, really came about because we were doing all this great work, but there was this bottleneck in how do we actually get the decision makers to use this work. And so what we did starting in about 2021 was we got some funding from the ARDC in Queensland and the DAF, and we put together a proposal about developing this cloud-based analytics platform that was ultimately informed by a series of user requirement workshops on what's the key analytics to inform different decisions. And we wanted to do this in such a way that it was accessible to everyone, so not just staff, but the state jurisdictions, industry, and researchers. And so it's open access. And what we came out of it was a series of analytics that were useful in biosecurity decision making. So these included things like species distribution modelling for understanding the climate suitability of a threat, biosecurity risk mapping, which is slightly more sophisticated than just this climate suitability map. It thinks about the pathways of entry and how that risk may disperse across the landscape, but also the biotic component, so the habitat requirements or the host availability. Very useful for thinking about early detection modelling. Then we've got more sophisticated models, such as being able to simulate spread, and there's many different ways that the platform allows you to do that. But on top of that, you can simulate spread with and without surveillance and with and without different types of control measures. So you can impose movement controls. You might release a biocontrol agent that reduces the population growth rate of the threat. You might just go in there and remove hosts from a given radius around the infection point. There's many different algorithms and control measures that can be incorporated into these models. We've got impact analysis, so you can simulate either at a snapshot in time or across time based on a spread simulation, where how the damages to different assets will accumulate over time or at a given snapshot in time. It can feed into surveillance design. So where should you be optimally allocating your surveillance across space based on risk? And also, how many times do you need to revisit that surveillance network to get to a given level of confidence that the threat is absent, either in an incursion context, such as proof of freedom, or for market access, which is area freedom. So we've built a series of analytics that doesn't require the user to be a coder. It has a user interface defined by these user requirement workshops that had government members in it, researchers, industry members in it. And we're in the process, and particularly over the last 2 years, of refining these workflows so they're fit for purpose by developing a series of real-world case studies with different organisations. It could be local government agencies we've worked with. More recently, we've been working with industry partners such as AusVeg and FWPA, so the forestry groups. But there's also state government agencies that we've been working with as well. More recently, we've added some feasibility of eradication survey tool to help inform the consultative committee for emergency plant pests. So that's basically modernising the Excel spreadsheet that was used to help inform those discussions about feasibility of eradication. Through the HASTE project that some of you may be aware of, we've also recently added some animal disease models. And of course, we've got some GIS manipulation tools on the platform as well. Since its launch in about May 2023, we've currently got over 823 users, and there's roughly a 50-50 split between government and research users, and we've increasingly got industry users using the platform as well. Not from just Australia, but also outside of Australia. Next slide, Andrew. Just very quickly, the platform isn't just about doing analytics. We also have a curated database with over 59,000 spatial objects and other types of data sets. You have the ability to load your own data up in a secure sandbox account. We have API connections to a whole heap of different biodiversity databases, the most notable being the Global Biodiversity Information Facility that has billions and billions of occurrence records for many species. We have the marine equivalent, the OBIS, and we also have Atlas of Living Australia API connections. So you can directly pull data into, oh, something's happened to the slides, Andrew. I can't hear you, but the slides just disappeared.
Yeah, somebody else decided to share. What a blessing.
So we've got visualization on the platform. We're also, what we're particularly focusing on at the moment is to build this public library of case studies. So we've actually got over 51 real world case studies across a variety of different pests and diseases that can be used on the platform. Next slide. Some of the more recent work that we're doing is with the Australian Plague Locust Commission. So we're in the process of developing a monitoring web mapper that allows them as an operational tool to see in real time where monitoring is being done, what's being observed, and also allow them to overlay different types of spatial objects such as satellite imagery, so NDVI being one of them, or fractional vegetation cover, but also weather data that's been directly pulled in from the Bureau of Meteorology or silo weather data. Where we plan to go with this is not only are they going to have a tool that's capable of actually monitoring where they're doing their surveillance and what they're detecting, but we're going to integrate some of the more recent work that we've done in the machine learning space of short-term and seasonal forecasting models, so they can actually overlay their risk maps to inform that risk and where they should be doing their surveillance. Next slide. Just to finish up, the national benefits of this is that this is a cloud-based platform that is open access to everyone. So there's compute resources that are largely covered by the ARDC. They're available to everyone. You don't need to install anything on your computer. It provides easier access to data and these cutting-edge analytics, some of which have been developed by CEBRA, some have been developed by others. The central goal is to produce standardized and reproducible and transparent risk analytics to inform these decisions. And through the platform, we also provide opportunities to foster collaboration by sharing projects between individuals. So this ultimately reduces redundancy and duplication among organisations, and ideally provides the opportunity for nationally endorsed frameworks for how these models are developed and how they're used to inform operational and policy decision making. The last slide, Andrew. And I'll just finish it up with a thank you to all the various partners, DAF included, and the Commonwealth Government, Queensland Government, the APLC, ARDC, and our industry partners, VegWatch and Forest Wood Products Australia, and also the work that we've been doing in the HASTE project in the animal disease space.
Thanks, James. I'm going to call on Richard.
Hello. So, as always, I preach a righteous wind about ADIS, the Australian Animal Disease Spread Model, a DAF initiative in 2012, and started out just as a humble FMD model, and then it got dramatically out of control. So what it is, it's a complex simulation model, allows us to simulate the release of a pathogen anywhere in Australia on any day. And it explores different possible spread modalities and gives an idea of what might happen on a daily time step where this disease might get to. And the whole point of it is it allows us to do experiments on potential response options, the cost effectiveness of different options that are on the table, such as vaccination. Being a simulation, it explicitly represents people. So if we need a veterinarian, it has to find one from the pool of veterinarians and sends a veterinarian out to do a surveillance visit. It represents or simulates the effectiveness of our contact tracing, how well we can stamp out disease. So all of these things operate together to allow wargaming and also to assist with real-time response. Next slide, please, Andrew. So, and then we'll just go to the next one, because this really just sums up the story. So we started out doing contagious livestock disease in 2014 with FMD, African swine fever. Over in Europe, where we were doing PPR, sheep and goat pox, classical swine fever. And then next one, Andrew, please, we went to vector-borne disease. So we started looking at blue tongue. And for that, we needed to incorporate insect populations, the dynamics, and the potential relationship between insects and livestock. So that expanded to mechanical vectors, lumpy skin disease, Japanese encephalitis. And then next from there, please, Andrew. The project in 2020, we looked at feral pigs. So the ASF model and the FMD model were just doing the domestic situation at that point. We expanded. So at this point, the model was well and truly becoming a framework. So handling not only domestic farms, but also layers of insects, raster layers of insects for feral animals. And then the next slide was an odd experience. We went and did some plant pest work. So that was yellow crazy ant, oriental fruit fly. But this was actually a tremendous thing, because this just, personally, I learned a lot more about the nuances of representing insect populations. And that directly informed the vector-borne work that came after that. There was another little rabbit hole we went down, which was human disease. And the plan then was that we thought at one point we would explore zoonoses. So the relationship between diseases propagating in systems such as livestock, but then potentially spilling over to wildlife and spilling over maybe to humans. So the framework at this point handles all these things, and the way it works is you've got the core down the bottom, and then you flavor the core with some configuration files, with some databases, and you end up with one of the boxes up the top. So the boxes up the top are the instantiations, the examples of the model, and the core down the bottom is the model, being all things to all areas. And then the last one there, thanks, Andrew, is response. So our bread and butter has been preparedness, so wargaming for what might happen. From there, we went to post-outbreaks, surveillance and management of vaccinated animals after an outbreak. And then the piece in the puzzle was response. And we started that actually in 2017 when there was a blue tongue scare in Victoria. So I've been adding different response attributes over the years. And at this point now, we've got this model that can do everything. So we've been using the response mode in Europe with PPR, with sheep and goat pox. In New Zealand, we've used the functionality looking at Mycoplasma bovis, and that is pretty much a whirlwind tour of ADIS. And then just the final slide and the take-home message. After all these projects, CEBRA projects with New Zealand and the jurisdictions, the ones that worked the best and the ones that I enjoyed the most was where we're actually working side by side with federal government, state government and industry. So there are certain projects there that were just wonderful to be part of. You know, we had people from those different points of view working together and solving problems in biosecurity. And I'm going to leave it there.
Outstanding. Thank you so much, Richard. I will now take over and I'll pretend to be Anka. Anka's unavailable because she's on a plane right now, which is a shame. Anka joined CEBRA way back in the dim, dark ages of 2010 or 11-ish. Anka specifically joined, actually, I'm sorry, she joined ACERA to work with Mark on the field of structured expert judgment. And look, I've got a mea culpa to address you all today. And somebody, I guess, will tell Anka about this. And that is, initially, I, as a statistician, I thought SEJ was honestly a bit of a gimmick. I didn't really see the bigger picture. And today I'm here to confess that I see the bigger picture. I've seen the light, and I'm going to tell you what it looks like. So CEBRA and ACERA developed a protocol for structured expert judgment, which is essentially a better way of getting people to do better informed and less biased guesses at unknown quantities. This is important because oftentimes we need to know something, and I'll go into this in a bit more detail later. We need to know something in order to help us make a decision. We can't find out what it is. We can't get the data, or if the data may not exist, it may be impossible, or we may be making a prediction about the future. Under any of these circumstances, we need to know something, but we can't go and collect the data in the traditional sort of scientific, let's say, objective way. So we're caught. We could just ask a friend, we could generate a random number, or we could try to do something better than both of those things, which is we could expose a collection of experts to a protocol that minimizes cognitive biases, both individual and collective, as much as possible, and then extracts information from them willingly. So CEBRA and ACERA developed this idea protocol. I won't describe it in great detail because there's a fair bit of complexity in there, and also I think most of the people here will probably have been exposed to it at some point or other. But essentially, it's a process whereby you get experts, you present them, you negotiate definitions with them, you present them with questions, that they must answer individually. You bring those together, you aggregate them, and anonymize them. You get them to discuss those anonymized results, and then you allow them to revise their estimates anonymously. And this process does the best job that we can think of in reducing cognitive biases to which otherwise we are subject. And it's well established that these cognitive biases exist and will perniciously affect our ability to make estimates if we don't handle them properly. Now, why is this important? Well, what we've discovered over the many years of working with the department is that the kinds of questions you can answer with statistical information are not very interesting questions and not very relevant questions. They're really part of the question. They're really part of the bigger question. And I've just got a couple of sketches of models here that we've used under fire that pivot on partially statistical information, but also structured expert judgment information for plugging those gaps where data simply can't be collected. And both of these models have enabled us to answer important large-scale questions on behalf of the department and other stakeholders that would be impossible in the absence of structured expert judgment. So there's my mea culpa. It's much more important than I imagined, and much more important than I would even let Anka know that I think. And I just also included a little graph here, that's in the top right, that shows you the kind of outcome that you get when you do a structured expert judgment. Each of those diamonds is an expert opinion, and the bars capture the uncertainty of those experts. And down the bottom, that beautiful green diamond, that's the average. And the average of the uncertainty sort of collated is presented at the bottom there. And that's the number you'd use, and you'd represent that uncertainty flowing through the system. That will give you good information on where you might want to invest future effort for free uncertainty. So that's an element that's been really important for us in CEBRA, is enhancing and normalizing the use of structured expert judgment. And we've developed an online platform and sustain that online. We support that online platform called Idea Ecology that allows people to do their own structured expert judgment exercises. And we have a long-term plan to integrate that functionality into Biosecurity Commons in a way that is tuned to the questions that Biosecurity Commons confronts the experts with, and integrates that for a better outcome. So we're very excited about that future development. Now I'm going to stop being Anka and start being me. My journey through ACERA began actually way back in 2006, when I started working with the border operations folks, or actually, sorry, it was a compliance division at the time, looking at some case studies on how we could balance risk against return. Now, you might recall that there was a foot and mouth disease outbreak in 2001 in Britain, and that occasioned the Australian government to lock down the borders most substantially. And they looked at various pathways. They looked at shipping containers, they looked at air containers, and they looked at passengers, and they also looked at reportable documents, or HVLV as they were called in the day. And they said, let's inspect all of these because any of them might be implicated as having FMD risk. Now we fast forward 5, 6, 7 years later, Field Ops has been doing countless of these inspections, 10 million containers inspected, countless air cans, etc. And it's not hard to imagine that they didn't actually find very much that was of direct interest for managing FMD risk. They found some feathers, they found some corpses, they found some skeletons, they found some pentagrams, but they didn't find much that was directly implicated. But there was a need to step back from that 100% investment, a wise need, let's say, but a tricky one, because as a regulator, it's always easier to do more than it is to do less. How do you justify doing less when you're a regulator? You gather statistics and you make a judgment. So fortunately, in its wisdom, DAF had been collecting the negatives, which is honestly quite rare on the international stage, let me say. And as a consequence, we knew we could analyze these data and come up with an indication of the actual biosecurity risk presented at the border. Okay, not necessarily the risk that would lead to an establishment. We undertook an analysis of these pathways, I did, and came to the conclusion that these are all low-risk pathways and worthy of surveillance, but not worthy of 100% intervention. And DAF implemented that years ago, decades ago. And nowadays it's commonplace for whippersnappers to say to me, oh yes, well, we just do a survey on these pathways for these reasons, totally unaware that these are predicated on my own blood, sweat and tears and data analysis, which is kind of comforting actually. So where do we go from there though? And what important lessons do we have from that? Where we go from that is we had a request from the plant folks to say, well, could you work this magic in the plant products pathways? And we said, well, why? Yes, of course we can. And we looked into how we might do that. We looked into trying to use the same approach that we used in these in the conveyance pathways, and found that the sample sizes are too small, couldn't do it. But instead we advocated using a simple algorithm that had been developed in the mists of time and formalized and published in the 1940s by a mathematician called Dodge. And these were the continuous sampling plan family. The continuous sampling plan is a very simple algorithm that you can use on a spreadsheet to see whether or not you should inspect something that's coming up or you should let it go based on the inspection history outcomes. I won't describe the algorithm, it's easy to look up, and we've got a CEBRAnar about it available on YouTube. So essentially we proposed the use of this simple algorithm in low risk pathways. DAF decided that they would try this in green coffee beans coming into Melbourne, a voluminous pathway, the immediate post-border treatment of which, of course, is to be roasted. No one drinks green coffee beans. Everybody gets them roasted. And there's very few pathogens that can survive roasting. And I'm not sure whether it would add to the flavor or not. Regardless, this low-risk pathway was attempted and established as a trial. And then you can see the sort of development of the policy in the slide there as more and more pathways came online and time passed and experiments continued and engagement continued. And we in the department were ably supported by ABES, and I'll talk more about that support in a future slide. So finally, we have this outcome of all the pathways that have been added to the CEBRA algorithm. It's quite overt, it's quite public, and it provides a really useful reduction in churn at the border that obtains across not only the pathways where it's applied, but other pathways as well, because it reduces the queuing at the border, because it allows consignments to be released as soon as docs are provided. So what we discovered then, after thinking about that and discussing it, was that the importers whose imports were on, the pathways were on the program, were actually very keen about this. We found that it enabled them to get their product more quickly, more efficiently, and more cheaply, and this created an incentive. And on that note, I'm going to hand over to Susie.
Perfect. Thanks, Andrew, and hi, everyone. So in this body of work, we're focusing on the strategic human behaviour aspects of biosecurity and deliberately designing rules that are going to get us the human behaviour that we are after at least cost. The important concepts I've tried to distill on this slide. And I guess we all know that we put regulations, policies, interventions, import conditions, whatever you want to call them, in place to manage biosecurity risks. In doing that, we're actually trying to manage the behaviour of our stakeholders, our regulated entities, humans. Presumably, if all stakeholders followed the rules, then biosecurity risks would be managed. The question we need to ask, though, is really, will our rules and regulations actually be followed? If we assume that regulated entities understand the rules, then those being regulated will actually think strategically about how they will respond to these rules. And we know this because we are also humans and we do this. We don't follow rules and regulations naively just because an authority put them in place. We think about what compliance or non-compliance might mean for us, for our businesses, for our community. So as humans, we are responding to the incentives that are inherent in all regulations, and this is true regardless of the domain of the economy, and regardless of whether the incentives are actually thought about or not in regulation design. So the graphic shows a very simplified decision tree for, let's say, an importer, and it shows that we need to make sure that we design a regulation where it's cheaper to comply than not comply. We might think that having a huge penalty might be an incentive to comply, but if we've chosen to make penalties enormous, but we don't have the resources to check compliance, stakeholders will work that out, or perhaps our import conditions aren't verifiable, so there's low likelihood that non-compliance will be detected, then it's likely to be the best decision to not comply for some importers. And I would suggest the regulation needs rethinking. So regulations that are designed without a focus on incentives and strategic human behaviour might just lead to the opposite behaviour to what we'd been intending or what we'd hoped for, and this can cost the taxpayer significant amounts of money. Next slide, please, Andrew. Okay, so do we really have incentive problems in biosecurity? Well, I would suggest yes, given little or no focus on deliberately designing incentives in regulations. And here is a list. It's not exhaustive, of where I think there could be problems related to incentives. Or if I'm going to be optimistic, I would say where there are opportunities to improve regulations and policies and save significant amounts of money. So if we just look at the first couple, for example, we have regulations that require farmers to report emergency animal diseases as soon as they are noticed. Farmers know this. But if reporting will result in financial and reputational ruin, I would suggest farmers may have an incentive to sell or destroy animals, and we have anecdotal evidence of this happening in the past. Another example of where we might have incentive problems are in those cases where we delegate biosecurity risk management to third parties. For example, to competent authorities or national plant protection organisations. In doing so, in delegating this authority, we're actually shifting decisions away from individuals who have strong incentives to act in Australia's interests to individuals who face weaker incentives to do so. So we need to be really careful in how we write those contracts and undertake that delegation, and so on. Next slide, please, Andrew. CEBRA's body of work on incentives actually goes back to 2013, to the work Andrew was talking about. And it started with a really useful relationship with the Centre of Market Design at the University of Melbourne and with the Plant Import Operations Group. We started with a series of projects affectionately known as the Carrots and Sticks group of projects. And we were asking whether the newly applied CBIZ inspection algorithm was creating the right incentives, or indeed, was it creating incentives for importers to take their feet off the pedal, so to speak, when they were in low inspection mode, when they'd passed their, let's say, 10 consecutive inspections. And we, through some experiments, some really neat economic analysis, we showed that yes, this algorithm could indeed create perverse incentives unless the importer had invested significantly in risk mitigation infrastructure. And so we went about suggesting how we might guard against that. In 2017, we looked at the incentives facing competent authorities in certifying their exporters. We worked with the Animal Division here and with Alan Mooney. So again, this is a case of where we delegate authority to an overseas organisation to certify the health status of imports we receive. We looked at finfish pathways, and we provided guidance on how we could improve the incentives facing competent authorities. And finally, in 2021, we started a 4-year project just completed in which we came up with a methodology to diagnose, check incentives and improve them in biosecurity policies. And we also progressed biosecurity risk insurance and applied it to biofouling. Next slide, please, Andrew. The challenge now is to operationalise all this good work that we've done. The little graphic on the right represents the incentive diagnostic tool, which basically is a series of questions that pathway managers would find answers to undertake a check of incentives or to roll out incentives that were incentive compatible. Please reach out if you want to apply the incentive diagnostic tool to your pathway. We need more case studies so that we can improve the tool, calibrate it further, and build the evidence base for what works. Thank you.
Thanks, Susie. Let's go, Tom. You've got 5 minutes.
Great. Thank you, Andrew. The value of biosecurity model, the CEBRA value biosecurity model. What's the value of biosecurity to the nation as a whole? That's what this model's been working on for almost a decade. But there's some really nice, recent, exciting developments to highlight. I've listed some of the names of individuals who've worked on this system, and I probably left some out, including James Kamak and Biosecurity Commons team, who've been helping us with calibrating BMSB recently. But it's a large, sustained effort over a series of years, and it's all coming good at the moment. Next slide, Andrew. Just put everything up. Well,
so I'm clicking and nothing's happening. Yeah.
Well, go to the next slide.
Thank you.
Yeah, so the value of biosecurity model is a large dimensional platform that asks the question, what happens if there's a change in the establishment rate? System on, system off, if we have a system in place like DAF versus not having it in place, and then tracks the spread throughout the nation of potential incursions of pests and diseases, and then finally calculates the impact in terms of losses in agricultural production, damages to the environment, and so on. The original model had this group of pests. There's now an additional 12 pests that are being added to the model. So it's a system-wide approach designed to avoid double counting, designed to look and see what the benefit is to the nation as a whole from having a biosecurity model in place or system in place. And what you get from this is, next slide, Andrew, as many of you will already have known, is a wonderful average rate of return. You look at the difference between avoided damages from having the system in place relative to not having it in place, compared to the cost of the system itself, how much is spent on biosecurity, and you get this fabulous rate of return of roughly 30 to 1. Big headline item at the time, and we're still working to refine this and get even better estimates going forward. But for me, the exciting part is the last slide, Andrew. It's the case now that this value model finally really runs in DAF. There's an R package and a Docker container that Matthew Cantelli and Fawn Van Ha have been working on and doing excellent work with the biosecurity modeling team in DAF to make it run in-house. And indeed, it does run in-house. They've been running it. We had a nice chat about it yesterday. It's more faster and more efficient than the previous versions, given the added C code and other refinements. And what we're thinking is now it's a clear move from a scientific programming model, its original sort of construction, to a more practical strategic planning model within DAF. Indeed, run within DAF by the biosecurity modeling team. So you can ask the question, what happens if there are changes in establishment rates? What happens, we can just look at all the plant pests as distinct from the animal pests. What happens if there's changes in the damage functions? What happens if there's changes in spread rates and so on? You can do all of this in a strategic setting within the model and form different kinds of experiments. We've been incorporating new pests, as I mentioned, and diseases, along with changes in pest pathways and asset layers, BMSB, myrtle rust, LSD, CAPRA going in. We're working on FMD, getting that correct and refined with new damage functions and new spread rates. And indeed, planning to introduce new pre-border measures. The work that CERA and CEBRA does with pre-border now is in fact allowing us to calibrate establishment rates in different ways, which I think is really quite important. We're adding a marine layer, and indeed for the future, we're putting in, again, improved pre-border layers and establishment rates, but also constructing post-border control measures, which are still absent from the model. And indeed, finally, it would be nice to add some value added to the model, right? At the moment, we're just getting an average return. But what's the bang for buck? Where's the best way to spend money across different kinds of pests and different kinds of biosecurity measures? There is a prototype model in place for New Zealand, which is still being worked on. But we need to do this for DAF as well. I mean, what's nice about all of this is that it's a unique global platform. It's the only thing it's the only place in the world where this is being done, along with New Zealand. And it allows us to do some really cool strategic planning. And working with the biosecurity modeling team in DAF has been a real pleasure. Actually, they've been great to work with. So we're gonna let you know what happens in the future. It's very exciting. And stay tuned. Thanks, Andrew.
Thanks, Tom. So I'm going to wrap us up now with three big lessons that we've learned over the past 20 years. The first big lesson is in the value of sustained engagement. We've talked about all of these programs that each CI has sort of had carriage of. And each of them involves a number of smaller projects that flow from one to another. If you think about, you trace the development of Biosecurity Commons, you trace the development of ACERA, even the risk return projects that I outlined and then Susie deftly captured and brought into the incentive space. And of course, the value model, all of these are large scale for us programs that comprise these smaller projects that came about because of the engagement model that we are lucky enough to have with DAF and with MPI. And I can't emphasize this point enough. The engagement model really drives and creates the environment in which we can have the success that we've enjoyed so far. And we're incredibly grateful to our partners and stakeholders for the engagement and for the trust that it entails. Because what it means is, instead of having a kind of transactional project by project lens where we're either on or we're off, the engagement model we have means that we're continually working with our stakeholders and with our partners to try to find better ways to do the stuff that has to get done. Even if that might involve just a phone call and a whiteboard, rather than having to write a proposal and get funding and or to be challenged for other sources of funding or any of those aspects, sometimes the best solution is a quiet conversation. And we're delighted that the engagement model enables us to work with our stakeholders at this range of levels. So sustained engagement, I think, is our first big lesson and really underpins our success. The second key lesson is the importance of making analytics more accessible and enabling better decisions to be made with the analytics. And this entails a big step away from the statistical niceties, tragically, and a big step towards thinking about how decision makers think, thinking about how they make their decisions right now, and with what information, with what evidence, with what risk appetite, in what environment, and how can we engage constructively with that process rather than just shoveling more statistics into the furnace and watching the train pull out even faster. So our goal there is to get to know the decision makers better so that we can lean in more effectively and provide actionable intelligence. And we've had a couple of projects just recently that have had really exciting implications in terms of developing actionable intelligence, stepping away from the statistical mores and more into what actually happens, what people are thinking, and what they need to know. And the third big lesson, and I can't emphasize this one enough, is the importance of partnerships that we develop and sustain with individual parts of our stakeholders, the groups. And I'm thinking really in particular of ABARES. We've had a 20-year relationship with ABARES that has just gone from strength to strength, and particular thanks to Tony Arthur and his incredible support over the past decades for us. And we can't emphasize enough how important it is that we have people inside the organization who can think in a way that links up with us and helps deliver those better outcomes within the body of the organization, but also helps extend those outcomes because of their different relationships and the greater knowledge they have of the needs of the organization. So having people on the inside, our insiders, the APLC, similar relationship, BAC, similar relationship, and we have parallel relationships with organizations inside MPI, and can't underscore enough the importance of those strategic relationships with those stakeholders. And we're incredibly grateful to all of them for working with us so tightly. Thank you so much. I'm going to wrap up now and leave this slide here, which is just all of the names that we could think of in the spur of the moment, thinking, oh, well, gosh, we've got to finish somewhere. So here we have everyone we could think of at the spur of the moment that we highly value, and can't thank you for your attention and thank you for your engagement. And we'll pause for questions at this time, but I'm going to leave that slide up there just for a moment.
Thank you so much, Andrew. And what an amazing accomplishment to fit 20 years of work into this short time we have together. And for me, just the reflection here is how you've really kept on pushing the frontiers of our biosecurity thinking, but done it in a way, and we can see that with things such as Biosecurity Commons and your approach to engagement, done it in a way that really brings all of us involved in the system along that journey. I think that's valued by many people on the webinar today, but I'll just see if there are any questions. I don't see any hands or in the chat. I mean, I guess while people are just having a think about that, Andrew and others on the call, I'd be interested in, we've reflected on the last 20 years. If we start to look forward, what do you think the most pressing biosecurity risks or challenges are? Where would you like to spend some of your time in the future of CEBRA?
So I'd like to spend significant amounts of our time getting closer to the decision-making process and getting closer to the decision makers. It's been a 20-year journey to just start to grapple with and understand the processes that folks go through when they make these decisions. I'm thinking about the Biosecurity Commons work. I'm thinking about Susie's work as well. Specifically, I'm thinking about how do people think about what they do when they do it. And I think for me, the analogy of shoveling statistics into the furnace really strikes me as being apt. Is that we're not really, if all we're doing is providing facts, we're not really engaging with the key issues. We want the things that we do, the things that we talk about, we want them to resonate with the decision makers in a way that the decision makers, when they see what we have to say, find it easier to make a decision, and find that, and that decision will be a better decision. It could be more efficient, it could be faster, it could be more resilient, it could be more transparent, any of these things. So I think the journey for us is to develop and enhance our programs so that they are better supportive, but also better reflective of the contemporary needs.
That's great to hear. I think from many of us on the call who do work closely with you, I think really encouraging. We'll just see if there are any other ask questions or comments from anybody who are on the call. Andrew, is there anything else you'd like to mention, or any one of your colleagues, or shall we wrap up a couple of minutes early?
Oh, I would never wrap up early. Let me stop sharing. If I can. How do I stop sharing? My goodness. It wants me to share something else. I can't do that. Well, I'll just continue to leave that up there because it's awesome. So the last thing, the thing I'd like to finish on, and I appreciate the opportunity, is I want to say how much we value this relationship with DAF and with MPI and with states and territories and with industry, and the multifaceted opportunities that these relationships create for us to innovate and deliver innovation to those stakeholders. The team is united in its passion for biosecurity and better biosecurity outcomes globally, and we cherish the opportunity to make contributions that are meaningful and significant, and we relish the opportunity to continue working with DAF. And yeah, to wrap up, I just want to say, probably just to repeat, how incredibly grateful we are, not only for your time today, but for your time over the last 20 years. Thank you so much.
Thank you very much, Andrew, for sharing all these insights today, and thank you also for your CEBRA colleagues who each have brought really interesting insights and reminded us, I guess, of the collective work that has been undertaken. So just to wrap up, to remind you that the recording for this will be available on CEBRA's YouTube channel shortly, and we're organising the next CEBRAnar for the 30th of July, so keep an eye out for that one. So thanks everybody for being here today, and I hope you all have a good rest of the day. Bye.